Hello everyone, welcome to AJJ Engineering. Today I would like to discuss with you about injection molding machine operation. Introduction. An injection molding machine is a machine for the converting, processing and forming of raw plastic material of powder, pellets or regrind into a part of desired shape and configuration. The process of injection molding consists of heating plastic material until it melts, then forcing this melted plastic into a mold where it cools and solidifies. The process of converting the plastic raw material into a melt of uniform temperature is known as plasticizing. Types of plasticizing units used are 1. Plunger injection, 2. Two-stage plunger, 3. Plasticizing screw, non-reciprocating, and a plunger, 4. Reciprocating screw. The reciprocating screw machines are widely used. Types of injection molding machines used are 1. Hand injection machine, 2. Horizontal injection molding machine, 3. Vertical injection molding machine, universal injection molding machine, 5. Multicolor injection molding machine, 6. Special purpose injection molding machine. The mold is held between the clamping platens of the machine. The clamping in most machines is of two types: mechanical, toggle, and hydraulic. An injection molding machine can be operated in three different ways. 1. Manual operation. It is an operation in which each functions and the timing of each functions are controlled manually by an operator. Semi-automatic operation. It is an operation in which machine performs a complete cycle of programmed molding functions automatically and then stops. It then requires an operator to manually start another complete cycle. 3. Fully automatic operation. It is an operation in which machine performs a complete cycle of programmed molding functions repetitively, stops only if there is a machine mold malfunction. It is manually interrupted. Clamping system terminology. Clamping unit. It is the portion of the injection molding machine in which the mold halves are clamped and which provides the motion and force to open and close the mold and to hold the mold closed with force during injection. When the mold is closed in horizontal direction, the clamp is called as horizontal clamp. When closed in vertical direction, the clamp is called as vertical clamp. There are a wide variety of clamping mechanisms available today, but majority of machines are either hydraulic or toggle operated. The choice between toggle and hydraulic clamp is not that critical and is often determined by individual preference. Moving platen. It is a member of the clamping unit which is moved towards the stationary member. The moving half of the mold is clamped to this moving platen. This member usually includes the ejector knockout hole and mold mounting pattern of thread holes or T-slots. Stationary platen. It is the fixed member of the clamping unit on which the stationary section of the mold is clamped. This member usually includes a mold mounting pattern of threaded holes or T-slots, tie rods or tie bars. These are the guides for the movable platen. This also serves as a tension member for the clamp during injection. Ejector knockout. It is a provision in the clamping unit that actuates a mechanism within the mold to eject the mold parts from the mold. The ejection actuating force may be applied hydraulic or pneumatically by cylinders attached to the moving platen or mechanically by the opening stroke of the moving platen. Full hydraulic clamp. It is a clamping unit attached by hydraulic cylinder that is directly connected to moving platen. Direct fluid pressure is used to open and close the mold and to provide the clamping force to hold the mold closed during injection. Hydraulic clamps are generally recommended for applications that require a clamping tonnage more than 500 tons. The advantages of hydraulic clamps are easy to adjust the clamping force, gives direct readout of clamping force remains constant throughout the operation. Toggle clamp. It is a clamping unit with a toggle mechanism directly connected to the moving platen. A hydraulic cylinder or some mechanical force devices is connected to the toggle system to exert the opening and closing force and hold the mold closing during injection. The clamping force to hold the mold closed during injection is provided by the mechanical advantage of the toggle. Toggle mechanism are preferred when the cycle time is less than 6 seconds. The advantage of toggle clamps are very compact and less cost for a clamp tonnage. Linkage automatically allows clamp slowdown, obviating additional controls. Slow mold open. A provision in the machine design enables slow platen movement for an adjustable distance during the initial opening of the mold. Clamp close slowdown. A provision in the machine designed to slow down the moving platen for an adjustable distance before the mold faces come in contact. Clamp open slowdown. A provision in the molding machine to slow down the moving platen for an adjustable distance before it reaches the maximum open position. This sequence is often employed to reduce the effect of knockout impact when mechanical knockouts are used. It is sometimes referred to the ejector or clamp open cushion. Clamp close stroke interruption. The clamp closing stroke is stopped to allow an auxiliary operation before completion of the closing stroke. Clamp open stroke interruption. The clamp opening stroke is stopped to allow an auxiliary operation before completion of the opening stroke. Clamp close preposition. A provision in the machine circuit to allow the clamp to open fully and then close to a predetermined position. It is generally used to allow the ejector knockout mechanism to retract so that the insert can be placed in the mold. Low pressure mold closing. A provision in the machine intended to lower the clamp closing force during the clamp closing cycle. The lower clamp forces minimize danger of mold damage caused by parts caught between the mold faces. Provision are also provided for parting mold faces at a time interval in case of an obstruction. Injection system terminology. Injection plasticizing unit. It is a portion of an injection molding machine which converts the plastic material from a solid phase to a homogeneous semi-liquid phase by rising its temperature. This unit maintains the material at a present temperature and forces it through the injection unit nozzle into a mold. Plunger unit. It is a combination injection and plasticizing device in which a heating chamber is mounted between the plunger and the mold. This chamber heats the plastic material by conduction. Each stroke pushes unmelted plastic material into the chamber, which in turn forces plastic melt at the front of the chamber out through the nozzle. Two-stage plunger unit. It is an injection and plasticizing unit in which the plasticizing is performed in a separate unit. It consists of a chamber to heat the plastic material by conduction and a plunger to push unmelted plastic material into a second stage injection unit. This injection unit serves as a combination holding, measuring and injection chamber. During the injection cycle, the shooting plunger forces the plastic melt from the injection chamber out through nozzle. Two-stage screw unit. It is an injection and plasticizing unit in which the plasticizing is performed in a separate unit that consists of a screw extrusion device to plasticize the material and force into a second stage injection unit. This injection unit serves as a combination holding, measuring and injection chamber. During the injection cycle, a plunger forces the plastic melt from the injection chamber out through nozzle. Reciprocating screw. It is a combination injection and plasticizing unit in which an extrusion device with a reciprocating screw is used to plasticize the material. Injection of material into a mold can take place by direct extrusion into the mold or by using the reciprocating screw as injection plunger or by a combination of the two. When the screw serves as an injection plunger, this unit acts as a holding, measuring and injection chamber. Adjustable injection rate. It is the ability to adjust the injection rate in step-less control between the maximum and minimum injection rate. Pre-pack or stuffing. It is a method that can be used to increase the volumetric output per shot of the injection plunger unit by pre-packing or stuffing, by adding materials into the heating cylinder by means of multiple stroke of the injection plunger. Applies only to plunger unit type injection machine. Plunger preposition. It is the position of the injection plunger by either limit switches or pressure switches so that total travel during injection is reduced. The primary purpose of injection preposition is reduce overall time by eliminating unnecessary plunger travel time during injection. Applies only to plunger unit type of injection machines. Dual injection pressure. It is the ability to select two separate injection pressure for timed intervals during the injection cycle. Nozzle retraction stroke. It is the maximum stroke of the hydraulic cylinder used to separate the injection rate unit from the sprue bushing of the mold for a cleaning and or purging purpose. Injection system specifications. Injection capacity or short capacity. Injection capacity or short capacity is the maximum swept volume or trapped volume in a plunger unit in centimeter cube that can be displaced by a single stroke of the injection plunger or screw, assuming no leakage and excluding the use of a rotating screw to displace additional volume. It is based on the volume of material that is available for injection. In short, it is given by the cross-section area of the screw or plunger multiplied by the length of the injection stroke. The short capacity is usually given in terms of the weight of the polystyrene material that will occupy the volume of prior to injection. For other materials, it must be calculated based on the specific volume of the molten plastic. Melt temperature and backup pressure affect the specific volume of the melt. Some amount of material will leak back past the screw during ejection. Thermoset injection capacity. Injection capacity can be measured in centimeter cube of swept volume, but there is no return valve on the thermoset screws. This figure cannot be used to convert to short weight because some material flow back over the screw during injection. The amount of backflow is dependent on variables in both the machine and molding materials. Hence, actual injection capacity cannot be absolutely defined. Plasticizing capacity. It is the maximum quantity of a specified plastic material that can be raised to a uniform and moldable temperature in a unit of time. This is usually expressed in kilograms per hour as available from a plunger unit. In this case of a screw unit, plasticizing capacity is generally expressed in kilogram per hour as calculated from the recovery rate. Injection pressure. It is defined as the maximum theoretical pressure of the injection plunger or screw against the material expressed in kilogram per centimeter square, assuming no loss of pressure due to frictional drag of the plunger or screw. At maximum force acting on the injection piston. Maximum injection rate. The maximum calculated rate of displacement of the injection plunger or screw expressed in centimeter cube per second computed at maximum injection pressure as specified. Minimum injection rate. The minimum calculated rate of screw expressed in cubic centimeter per second computed at maximum injection pressure as specified. Clamping system specifications. Clamping force tons. The clamp tonnage is a locking force in tons which is applied to the mold to keep it closed during the injection and cooling of the mold. It is the maximum force applied to the mold when it is closed for injection. Clamp opening force in tons. It is maximum force that a machine will exert to initiate the opening of the mold. Clamp stroke in millimeters. It is the maximum distance that the opening and closing mechanism can traverse a platen. This may usually be adjusted to shorter travel to meet mold or molding requirement. Opening daylight in millimeters. It is the maximum distance that can be obtained between the stationary platen and the moving platen when the actuating mechanism is fully retracted with or without ejector box and or spacers. Closed daylight or minimum mold thickness. It is the maximum distance between the stationary platen and the moving platen when the actuating mechanism is fully extended with or without ejector box or spacers. Minimum mold thickness will vary depending upon the size and kind of ejector boxes and the spacer used. Maximum closed daylight millimeters in millimeters. It is the maximum distance between the stationary platen and the moving platen. The actuating mechanism is fully extended without ejector box or spacers. Minimum closed daylight in millimeters. It is the maximum distance between the stationary platen and the moving platen when the actuating mechanism is fully extended with standard ejector box or spacers. Screw terminology. In the below images, we can see a different terminology used in screws. Helix angle, the root diameter, then flight depth, flight length, pitch, meter section, transistor section, and feed section. Then flighted length, the overall length, compromise flighted length and shank. Plasticizing screw. It is a helically flight shaft when rotated within the barrel, mechanically works and advances the material being processed. Screw flight. It is the helical metal thread of the screw. Screw root. It is the continuous central shaft, usually cylindrical or conical in shape. Flight land. It is the surface at the radial extremity of the flight constituting the periphery or outside diameter of the screw. Screw shank. It is the rear protruding portion of the screw to which the driving force is applied. Feed section of screws. It is the portion of the screw that pick up the material at the feed opening throat plus an additional portion downstream. Many screws have an initial constant lead and depth section. Transition section of screw. It is the portion of a screw between the feed section and metering section in which the depth decreases in the direction of discharge. Metering section of screws. It is a relatively shallow portion of the screw at the discharge end with a constant depth and lead. Screw diameter. The diameter developed by the rotating flight land about the screw axis. Helix angle. The angle of the flight at its periphery relative to a plane perpendicular to the screw axis. The location of measurement should be specified. Light lead. The distance in an axial direction from the center of a flight at its outside diameter to the center of the same flight one turn away. The location of measurement should be specified. Light pitch. The distance in an axial direction from the center of a flight at its periphery to the center of the next flight. In a single flight and screw, pitch and lead will be the same but they will be different in multiple flight and screw. The location of measurement should be specified. Flight depth. The distance in a radial direction from the periphery of a flight to the root. The location of measurement should be specified. Constant lead screw, uniform pitch screw. A screw with a flight of constant helix angle. Constant taper screw. A screw of constant lead and uniform increasing root diameter over the full flight and length. Decreasing lead screw. A screw in which the lead decreases over the full flight and length, usually the constant depth. Screw channel. With the screw in the barrel, the space bounded by the surface of flight, the root of the screw and the bore of the barrel. This is the space through which the stock is conveyed and pumped. Screw channel depth. The distance in a radial direction from the bore of the barrel to the root. The location of measurement should be specified. Compression ratio. The factor obtained by dividing the developed volume of the screw channel at the feed opening by the developed volume of the last full flight prior to discharge. Typical values ranges from 2 to 4, also expressed as ratio 2:1 or 4:1. Screw speed. Number of revolutions of the screw per minute. Plasticizing unit specification. L/D ratio. The common denominator used the compression of all. Barrel length to diameter ratio L/D. The distance from the forward edge of the feed opening to the forward end of the barrel bore divided by the bore diameter and expressed as a ratio wherein the diameter is reduced to 1, such as 20 by 1. Screw length to diameter ratio, L by. The distance from the forward edge of the feed opening to the forward end of the screw flight divided by the diameter of the screw expressed as a ratio. It is not based on the full flighted length of the screw. Construction of screws. The main element of a typical reciprocating screw unit are a barrel, a motor used to rotate the screw, and an injection ram by cylinder used to give axial movement of the screw in the barrel. For molding thermoplastics material, the barrel is usually fitted with electrical heater band on the outside diameter, and the thermocouples are used to control the temperature of the melt. Electric or hydraulic motors are generally used for screw rotation either directly or through a transmission system. Hydraulic motors have the advantage of supplying constant torque over wide range of speed, whereas electrical motors are more energy efficient. By supplying pressurized hydraulic fluid to the cylinder, necessary pressure can be developed on the screw in order to inject the material into the cavity. The cross-sectional area of the ram at the receiving area of the pressure is much larger than the cross-section area of the barrel. So a greater pressure is transferred to the melt than what is there in the hydraulic cylinder. The material from the hopper falls at the rear end of the barrel by gravitational force or transferred by some other feeding device. For less viscous and thermally stable materials like PP, a non-return valve is attached to the front of the screw to avoid the backflow of the material. However, for high viscous and thermally degradable material like PVC, a smear head is often substituted for non-return valve. But with this arrangement, some backflow may occur, which may be minimized the reduction of flow area. Sequence of operations. The sequence of operations for a reciprocating screw is injection. Screw moves axially forward, short preparation. Screw rotates anti-clockwise and retracts, soak or idle time. There is no screw movement. At the starting of the molding cycle, reciprocating screw occupies a retracted position in the barrel, and a charge of molten plastic occupies in region of the barrel bore between the front of the screw and nozzle. When the mold house have been closed and clamp pressure applied, hydraulic fluid is supplied to the injection cylinder, causing the injection ram and the screw to move forward, thereby injecting material through the nozzle and into the cavity. This pressure is known as injection pressure. When the cavity is filled, a certain percentage of injection pressure is maintained in the injection cylinder until the molten material in the gate solidifies. This pressure is known as holding pressure. During this period, additional material is also pushed into the cavity, known as packing the cavity, in order to compensate for the shrinkage to a certain extent. A new charge of polymer melt can be prepared for injection into the mold for the next shot. Screw rotates begins in the anti-clockwise direction, and material is carried forward along the screw. During its passage along the screw, the material is melted and mixed, and it is discharged from the forward end of the screw. Pressure generated in the discharge melt is transmitted by screw to the injection ram, which displays hydraulic fluid from the injection cylinder and allows the screw to retract in the barrel. By controlling the free flow of fluid from the injection cylinder, the pressure acting on the molten material can be changed. This procedure is termed application of back pressure. When the required volume of the melt has been discharged, the screw rotation stops. Process of shot preparation is termed screw back. Once the new charge of plastic melt for the next shot has been prepared, and when the solidified part in the mold cavity has been ejected and the mold is closed, the next molding cycle can begin. In general, there can be a period of time between the end screw rotation and the start of injection. Any such delay is termed soak and idle time. Types of screw design. In order to overcome many of the performance limitations of conventional screws, a number of specified designs are available with emphasis on plasticizing process. Local mixing screws. Local mixing sections are typically short device designed to generate high rates of melting or mixing at the delivery end of the screw. The choice of the device is normally depend upon whether the melting or mixing should be given importance. Extended mixing screws. Extended mixing screws have got more length for the mixing section. One method is using double wave fluid. In this method, two long melt channels are made in parallel with each other with periodically varying depth. The shallower depth provides high shear rate with periodic changes in pressure. By arranging channels fluids out of phase with each other, material from one fluid can be periodically changed to other fluid. In most molding applications, extended mixing screws are used to accelerate last stage melting process and also to increase mixing. Barrier screws. Barrier screws are specially designed for controlling the melting process. The control is achieved through the use of tin channels in the central melting section separated by an undercut barrier plate. One channel is referred to as the solid channel and the other as the melt channel. Solid material is trapped in the solid channel until melting occurs. Molten material is conveyed from the top of the bed and is collected in the melt channel. The gap between the barrier plate and the barrel is critical, as it should not allow any solid particle go out of the trap. Through the length of the melting section, the volume of the solid channel progressively reduces and the volume of the melt channel progressively increases. When all materials have been melted, the solid channel is ended and the melt channel becomes the metering section. Barrier screws are extensively mainly used in extrusion process in order to improve the stability of the melting process. The use of barrier screw in injection molding is very rare. Low shear screw. It is a specialized screw design with a flighted cross section only in material conveying zone. There is no flight in the melting zone. Therefore, the melting is mainly due to the heat from the heater band. These types of screws are required when the additional mixing may damage the property and inhomogeneous structure of the material. Mainly fiber reinforced material use this type of screw. Vented barrel injection molding. Generally, materials that are moisture sensitive will have to be dried before molding. Vented barrel injection molding machines are capable of removing the moisture during the processing of the material. Vaporized water and other volatiles can be removed by using a vented barrel molding machine. Another method used to remove the moisture is by using pre-dryer. But in most cases, the more practical approach is the use of vented barrel. This type of drying requires a two-stage screw and a barrel incorporating a vent pod as shown in the figure. Molten material leaving the first stage of the screw enters a zone with a large cross-section and with a greater flight depth. So the area is not fully filled with the material and hence the pressure also drop equal to atmospheric pressure. The volatiles are released into the air at the end of the second stage of the material is again compressed to generate pressure necessary for to the flow through the non-return valve. Sequence in the molding operation.